To calculate residues involving trigonometry function, let's see some of the problems. Remember sin theta equal to e to the power I theta minus e to the power minus I theta by 2i. Put e to the power I theta equal to z. So e to the power minus I theta will be 1 by z. So the formula will be 1 by 2i into z minus 1 by z. Similarly, cos theta equal to e to the power I theta plus e to the power minus I theta by 2, that is half whole into z plus 1 by z. So remember these two formula. Let's see this question. Integrate 0 to 2 pi d theta by 5 minus 3 cos theta. Put the formula of cos theta here. That is half z plus 1 by z. Then simplify the equation. Take the minus common, that then in case of e to the power I theta, take it as z. Take the derivative of e to the power I theta and derivative of z, that will be I e to the power I theta, I e to the power I theta d theta equal to dz. So d theta will be e to the power I theta is z, so iz, d theta will be dz by iz. Put dz by iz in place of d theta. Then simplify the equation. Take minus as common. That will be minus 2 by I as taken to outside. So this is the fz. Our fz is this term. Find the poles of fz. To find the poles, this is the quadratic equation poles. Minus b plus minus b square minus 4ac, as you all know. That then the pole will be 3 and 1 by 3. So the poles are 3 and 1 by 3. Simplify the equation into factors, the quadratic equation into factors. That will be 3z square minus 9z minus z plus 3. 3z square common, that is z minus 3, minus 1 common, z minus 3. So the two factors are z minus 3 and 3z minus 1. Put it in place of the quadratic equation. It is a unit circle, so see which poles are within the circle. 3 will be outside the circle, only 1 by 3 will be within the circle. So we have to find the residue at pole 1 by 3. This is a simple pole. I have told you how to find the simple pole. That is limit z to the power 1 by 3, z minus z fz. Fz is minus 2 by I. This is the fz. I have told you minus 2 by a, 1 by z minus 3, 3z minus 1. Then simplify the equation and put z equal to 1 by 3 in place of z. We have the answer. To find the Cauchy, to find the answer of this integral, we have to multiply 2 pi I into the residue. The final answer will be pi by 2. Remember the general form. This is a. If we take 5 as a and 3 cos theta 3 as b, 5 as a and 3 cos theta as b, and a is greater than b. So these type of equations, for these type of equations, remember a formula that if it is question is written as d theta divided by a plus minus b sin theta, or d theta divided by a plus minus b cos theta. That previous question is a minus b cos theta, and a is greater than b. A is greater than b. So always the answer will be 2 pi root over a minus b square. Verify this answer. Remember this answer. So for CPET, since one question carries 1 minute, so you can apply this formula direct. Test here. Here 2 pi root over a square is 5, 25 minus b square, b is 3, 9. 2 pi by 16 root over 2 pi by 4, that is pi by 2. The final answer is pi by 2. Verified. So this formula, remember this formula. This is important. Another question. Cos 3 theta by 5 minus 4 cos theta 0 to 2 pi. In place of cos 3 theta, we can take it as cos 3 theta plus I sin theta. We can write it as like this: cos 3 theta plus I sin theta, that will be e to the power 3i theta. So cos 3 theta means real part of e to the power 3i theta. That is the real part, this is the imaginary part. So we will solve the question taking real part of e to the power 3i theta. 3i theta means if e to the power I theta is z, then 3i theta is equal to z cube. Put z cube here and d theta equal to dz by iz. Find the poles. In place of cos theta, put 1 half z plus 1 by z. Solve the equation. Make it as quadratic equation. Quadratic equation is take minus 1 by I to the outside. Quadratic equation is 2z square minus 5z plus 2. These are the two factors of quadratic equation. What are the poles? Half and make this factor equal to 0. The poles will be half and 2. Half and 2. Two will be outside the circle and half will be inside the circle. So we have to find the residue which is inside the circle, that will be half. Half is a simple pole, so z limit z to the power half, z minus half, z that is fz, z cube by 2z minus 1, z minus half. Then solve the equation and put half in place of z. Answer is minus 1 by 24. Since we have taken the real part of this, it is already in the real part, there is no imaginary question. So the answer is minus 1 by 24 into 2 pi I into minus half, minus I. And the answer, final answer, I will be cancelled. This is the real part. Answer will be pi by 12. Another question, you have to solve this and give answer in the comment. D theta divided by a plus minus b cos theta whole square. The answer will be 2 pi a. Better to remember the formula, as for one question it is 1 minute. So if you remember the formula, it will be easy to find out the answers. The answer will be 2 pi a square minus b square to the power 3 by 2. Important formula. And for sin theta, a plus minus b sin theta whole square, the same formula. Remember this. Then take another question. Integrate 0 to 2 pi e to the power cos theta, cos sin theta minus n theta d theta. Take cos theta sin theta minus n theta plus I sin theta sin theta minus n theta. This is e to the power I sin theta minus n theta. Then solve the equation. Cos theta plus I sin theta, cos theta plus I sin theta e to the power minus n I theta. Take e to the power I theta as z. D theta equal to dz by iz, as I told you before, and e to the power minus ni theta means e to the power 1 by e to the power ni theta, means 1 by z to the power n. So the answer will be minus I. Why it is minus I? That I by I square, that is 1 by I. Ez by z to the power n plus 1. The pole is a order pole. Order is n plus 1. Put the formula 1 by n plus 1 minus 1 factorial d to the power n plus 1 minus 1 by dz n plus 1 minus 1. Then z to the power n plus 1 minus I e to the power z by z to the power n plus 1, and here a is 0. A is 0. So find the limit at z equal to 0. After solving the equation, answer will be 2 pi by n factorial. Solve this equation and give answer in the comment. If the integral is in the f1x by f2x form and f2x has no real roots, and if f2x degree is greater than f1x, then you can apply this contour integration half semicircle formula rule. So how it is, let's see one question. Integrate 0 to infinity cos mx by x square plus 1 dx. As I have told you, solve this integral taking the real part of e to the power I mx. Put z in place of x, e to the power I mz minus infinity to plus infinity z square plus 1 dz. Find the poles of z square plus 1, that will be plus minus I. We have to calculate the residue of those poles which are on the upper half of the semicircle or on the real axis. Minus r to plus r. So minus I will be in the lower half. We have to calculate the pole for z equal to plus I. Z equal to plus I. Z equal to plus I. It is a simple pole, so limit z tends to I, z minus I e to the power I mz, z plus I, z minus I, that will be e to the power minus, put I in place of z, that will be I square e to the minus m by 2I. To find the answer of this integral, 2 pi I into the residue, the answer will be pi to the minus m. The answer is for minus infinity to plus infinity. For even functions, if it is a even function, and it is even function since it is x square is an even function. Even function we can write minus infinity to plus infinity as 2 0 to infinity fx dx. So since it is a real part and the answer is in the real part, answer will be this, cos mx by x square plus 1, 2 will be to that side, so pi by 2 it will minus m. So can you guess the what will be the answer of sin mx by x square plus 1? It will be 0, because there is no real no imaginary part in the answer. So if the question has given this, the answer will be 0. Remember this. Take another question, that is dx by 1 plus x square cube 0 to infinity. Again solve the question by taking it minus infinity to plus infinity. Find the poles. As I have told you how to find the poles, make the denominator 0, z plus I, z minus I, and order 3. The pole will be of order 3. Pole will be of order 3. Then put the formula of order pole, that is 1 by 3 minus 1 factorial d square by dz square z minus I cube by z plus I cube, z minus I cube, z tends to I. Then find the derivative, double derivative of z 1 by z plus I whole cube, and put I in place of z. The final answer will be 3 by 16I. Into you have to find the integral by into 2 pi I. Answer will be 3 pi by 8. We have found the answer from minus infinity to plus infinity. So for 0 to infinity, the answer will be 3 pi by 16. 3 pi by 8 into half. 3 pi by 16. Okay. Then this is another question, dx by 1 plus x6. You have to apply De Morgan's theorem here. For De Morgan's theorem, you know that z6 equal to minus half will be cos 2n pi plus pi, or 2n plus 1 pi plus I sin 2n plus 1 pi, to the power here to the power 1 by 6, that will be 6 goes to the denominator. So z will be cos 2n plus 1 by 6 pi plus I sin 2n plus 1 by 6 pi by 6, and n value will be 0 to 6 minus 1, the order less than 1, so 0 to 5. Find the values of n. Find all the values of n by putting n equal to 0. That will be cos pi by 6 plus I sin pi by 6. We can write it e to the power I pi by 6. Cos pi by 6 equal to 180 by 6 cos 30 root 3 by 2 plus I by 2. Similarly for n equal to 1 cos pi by 2 plus I sin pi by 2 e to the power pi by 2. Answer will be I for n equal to 2, and locate it in the semicircle. Which one comes in the upper part of the semicircle and which one comes in the lower part of the semicircle? Please comment. For n equal to 2, answer will be cos 5 pi by 6 plus I sin 5 pi by 6 e to the power 5 pi by 6. Then for n3, n4, n5, here see one thing. This cos 5 by 6 equal to cos pi minus pi by 6. That will be my cos minus pi by 6. That will be minus root 3 by 2 plus half plus I by 2. Similarly, find the answers for e to the n3, n4, n5. You will see that n3, n4, n5 will be in the lower half of the semicircle and these three are in the upper half of the semicircle. So, find poles for n equal to 0, n equal to 1, n equal to 2. As I have told you one formula of the residue to find the residue of a fraction, I have told you make it pi x psi dash x. So we have to make the derivative of the denominator 1 plus z6. We have to make the derivative to find residue. Then limit z tends to e to the power pi by 6. Derivative will be 6z to the power 5. Put e to the I pi by 6 in place of z. Answer will be 1 by 6 e to the power minus 5 by 6. That goes for n equal to g1 and n equal to 2. Make the sum of these residues. The value which you have find out. Find out the sum of these all three residues and multiply it in 2 pi by 2 pi I. Answer will be 2 pi by 3. We have found the formula for minus infinity to plus infinity. So for 0 to infinity, answer will be pi by 3 by 2. This is one question. It is homework for you. You will find the answer. Look at this question. Cos 3x dx by x square plus 1 x square plus 4. Find the poles. Replace x equal to z and find the poles. So for this z equal to plus minus I and for this z equal to plus minus 2I. Plus minus, it is minus I and it is minus 2I. We cannot find the poles for minus I and minus 2I. So we have to find the poles for plus I and plus 2I, and it is in the upper half of the semicircle. These are simple poles. To find the pole, limit z tends to I, z minus I f z. Z minus I will cancel out and put I in place of z. Find the answer. For z tends to 2I, limit z tends to 2I, z minus 2I f z. Put 2I, z minus 2I will cancel out. Put 2I in place of z. Find the sum of these two residues. Then multiply it into 2 pi by I. Since we have found the answer for minus infinity to plus infinity, so for 0 to infinity, answer will be by 2. Okay. So I have covered almost all the questions for calculus of residues. That will be helpful for CPET 2026. For more such videos, please like, share, subscribe and comment on this channel so that I can improve. If you like short videos, then comment short videos, and if you like long videos, then comment long videos. I will make videos accordingly for CPET 2026. Thank you.